Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. Now this is a new question coming in front of us. Given a string S of alphabets, you need to write a function recursively that prints a new string which has all characters of S except any occurrence of the character X. So wherever you see a X, just trim it out. For example, you have something like ABC, XX, AD, X, AC, XE. So A will be in the answer, B will be part of the answer, C will be part of the answer. These X needs to be trimmed. Then A, D will be part of the answer, this X will be trimmed. A, C will be part of the answer, X will be trimmed, and then E. This is what you have to actually implement. And you have to do it recursively, of course. So we can write a very basic function, to be very honest. First of all, you definitely need the string as the input, str. Whatever string is coming, you need the string as the input. And string is very similar to array. It's not exactly array, of course, I know that. But it's pretty similar to array. You do a index by index access to a string. If I ask you to print a string index by index, you will put a loop. Instead of just if I ask you to print index by index. So here also we need to traverse the string index by index. So in a similar way, how we used to keep it for arrays, I will keep an index for string, right? And we will say that this function trims every occurrence of X in str from index idx to n-1. Starting from the index idx till the very last index, it removes every occurrence of X. And how do you do that? You will say if. So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our system design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video.
str of idx is equals to x. In Java, you will be comparing it with char at. If you're using C++ or something, then this kind of syntax directly works, right? If this is equals to x, don't do anything. Else, if it is not equal to x, just print str of idx, right? As it is, right? I just asked you to print something. So just print it, okay? And what will be the base case? What will be the base case? If idx becomes greater than or equal to str.length, you don't need to do anything because there are no more characters. As simple as that. So if you implement remove occurrence of x.java, okay, we need a string, we need an index. If index is greater than or equal to str.length, we return. Otherwise, we check if str.char@index is equal to x, we just leave it. Else, we print it. That's it, right? So, and in order to simplify this, you can write if the character is not equal to x, then only you print it, otherwise you don't do anything. So this is a more simpler way to write the same thing. And once you have taken a call on this, then what you can do, you can expect to print everything from idx plus 1 to n minus 1. Pretty similar to how we print arrays, right? We'll call for str comma idx plus 1. That's it. Let's call so initially what we want everything from 0 to n minus 1, right? If you run it, here we go. All the occurrences of x are actually gone, right? And if you carefully see, this is a pretty efficient approach because you are just traversing every character one by one. Okay, so this is good. And you might realize this question is not even adding much of a value. But the thing is, with this question, I generally introduce a new pattern of approaching a recursive problem. A lot of time in recursive problems, what you will be expected to do is you will be expected to, instead of just counting or doing maximization or minimization of something, you might be asked to print something. Maybe print all possible ways to do a particular task, right? So whenever you have to apply some printing logic, I really use this approach a lot. What you can actually do is, you can take a string or whatever is the input. Maybe this can be an array as well, right? But the interesting part is the third argument that I keep. The third argument generally I keep as a string, output string. Okay. And in this output string, I try to actually produce some values. And in the base case, I generally try to use this output to print the stuff. For in our case, what I can do is I'll say if str at idx not equal to x, I will say output plus equals to str of idx, and then I will call for f of str comma idx plus 1, and output has been already updated, so I'll pass output as it is, right? And then in the base case, I will print the output. Okay, you might feel it's a pretty simple strategy, but you will realize that for very complex question, this strategy is going to be a game changer for us. Okay, so I'll copy everything from here, paste it here, and I will pass a string output. Okay, I'll pass a string output, and what I'll say is that if str.char at I is not equal to x, then what I will pass is I will make a function call to str comma idx plus 1, and I'll append str.char at idx. Otherwise, I will not append anything. Otherwise, I'll not append anything and just move forward. That's it. And why I am like, although I wrote it output plus equal to like this here, but why I'm not implementing it like this, because I told you, right? I don't want to update my local copy of the variables, right? So when the function call comes back, output still remains like the original output, and in the function call that we made, there the output will get updated. And initially there is nothing in the output, so we print we pass an empty string, and in the base case we can print output. Let's try to dry run this code. And before dry running, let's reduce the input size, okay, to this. So you can see currently you are at index 0. Okay, you go here. Is index 0 greater than length of the array? No. Now, is the current character at index 0 equal to x? No, it is equal to a, right? So what will you do? You will make a function call such that the remaining characters can be printed, and in the output you will append the current character a. So can you see? Let's go here and okay. There are multiple bunch of internal functions that actually are called, right? And then you can see I have appended a here, right? I have appended a here. Okay, now we are at index 1. Is 1 greater than the length? No. Is the current character b equal to x? No. So what do? You again try to just append the character b, right? You again try to append the character b. Let's now again go inside this, and here we go. One second, what happened? Oh, we came back. One second. I don't think F10 works here. Let's try again. Sorry. Here we go. Okay. Let's try output this. This will call a bunch of functions. And you can see we are at index 1. Again, this is not equal to x. Again, this will be calling a bunch of internal functions. We can just escape them. Right. Oh, my bad. It's a bit hard to dry run a bunch of strings here. Just a second. Let's give it a last shot. Okay, here we go. And go inside. I guess there's a shortcut. I'm forgetting that shortcut. F10 doesn't work in my system. Not sure. Okay, we are at index 1. Okay, looks good. Let's go here. Okay, now we'll go to index 2. You can see now we are at index 2, right? Same thing will happen at index 2. And now you can see we are at index 3. Now at index 3 there is C. It is not equal to X. So again we will use it, right? So now we are at index 4, right? Now at index 4, 0, 1, 2, 3. Oh, I guess it skipped 3. Why? Because now we went into the else condition and didn't append anything. See, now we just have ABC, and now we are at index 4. Index 4 is D, right? So this will actually go inside and append D. So now if you run it, you get A, B, C, D, right? So it's a pretty simple approach, right? And currently you will feel like not a lot actually happened, but later you will realize this is a pretty efficient thing to do, at least in terms of writing the logic. There are a lot of space issues and time issues with this approach, but generally in recursive problems, there is not a lot of scope to optimize how much time and space your code is taking. We'll discuss that later in time and space complexity. But at least to solve very complex questions, this approach of keeping an output string here is going to be a game changer for us. I can give you like n number of questions where if you will just keep something like this, your life will be sorted. I hope this particular approach makes sense to everyone.